Inflation theory implications for extraterrestrial visitation. The ever-recurring question of why Earth has seemingly not been visited by extraterrestrials has received considerable discussion under the topic of Fermi's paradox. Whether one assumes the existence of only one other civilization, or of many alien civilizations, in the Milky Way galaxy, and whether one assumes colonization involving interstellar travel at near light speed or far below, diffusion modeling predicts colonization or at least visitation of all habitable planets in the galaxy on timescales of tens of millions of years. So the paradoxical question must be asked, where are the extraterrestrials? Theoretical possibilities unknown to Fermi make the paradox even stronger today. One can now rationally conjecture about prospects afforded by adjacent M-brane universes. Indeed, if the multi-dimensions underlying superstring and M-brane theory are correct, there could be inhabited universes separated from our own by small orthogonal distances. Also, anthropic reasoning has recently been applied to inflation theory, arriving once again at the conclusion that you should find yourselves within an enormously larger galactic civilization. While the solution to Fermi's paradox, which implied that life only existed on Earth, was once a seemingly valid solution, this answer is now incompatible with the infinite universe and random self-sampling assumption consistent with inflation theory. Thus, you find yourselves in the curious position that current cosmological theory predicts that you should be experiencing extraterrestrial visitation. At the same time, current physics and astrophysics suggest that such visitation may not be as impossible as had been thought. In recent astronomical discoveries, over 100 exoplanets have been catalogued, with detection sensitivity now increased to the point where, in one instance, a Jupiter-sized planet was deduced to be in a Jupiter-like orbit around a Sol-like star. In the field of exobiology, much recent activity suggests that some of the building blocks for life may originate in space as well as be transported by meteorites. The possibility of widespread panspermia has received new impetus. These findings and studies make plausible the hypothesis that there is intelligent life elsewhere in the universe. This is, of course, the fundamental assumption made by the proponents of SETI, the search for extraterrestrial intelligence using microwave or optical means of detection. The extraterrestrial hypothesis, that intelligent life from elsewhere in the universe could be visiting Earth, has become less implausible through suggestions that the velocity of light constraint is not as restricting as had been assumed previously. This restriction has its origin in the special theory of relativity. However, within the context of general relativity, there are three approaches which may permit legitimately bypassing this limit, given sufficiently advanced knowledge of physics and technology. One approach concerns the possibility of wormholes, or cosmic subways, a form of shortcut through the space-time metric. Using the standard general theory of relativity as a basis, certain mathematical requirements for traversable wormholes have been derived and published in the scientific literature, and, it appears, that there is the possibility of engineering a wormhole metric, at least in principle. A second more recent approach is the Alcubierre warp drive. Unlike the speed of light limit through space, there is no limit to the speed at which space itself might stretch. Faster than light relative motion is part of inflation theory, and presumably the universe beyond the Hubble distance is receding from us faster than the speed of light. It was shown that a spaceship contained in a volume of space, could in principle, make use of faster than light expansion of space-time behind, and a similar contraction of space-time in front, with the inconvenience of time dilation and untoward accelerations being overcome. A related approach involves constructing a tube to connect spatially remote locales. Of course, so-called exotic matter would be required for either case. If the general theory of relativity itself were to be reinterpreted in terms of a polarizable vacuum, this would open the possibility of a different type of metric engineering in which the dielectric properties of the vacuum might be altered in such a way as to raise the local propagation velocity of light. In effect, one would be creating a local index of refraction of less than unity. Finally, there is the conjectured possibility of making use of the additional dimensionalities of M-brane and superstring theory, to transfer into adjacent universes where the speed of light limit may be quite different, and re-entering your universe at the desired location. This is by far the most speculative possibility. Clearly, when it comes to engineering warp drive or wormhole solutions, seemingly insurmountable obstacles emerge, such as unattainable energy requirements or the need for exotic matter. Thus, if success is to be achieved, it must rest on some yet unforeseen breakthrough about which you can only speculate, such as a technology to cohere otherwise random vacuum fluctuations. Nonetheless, the possibility of reduced time interstellar travel by advanced extraterrestrial civilizations is not, as naive consideration might hold, fundamentally ruled out by presently known physical principles. Extraterrestrial knowledge of the physical universe may comprise new principles which allow some form of faster than light travel. This possibility is to be taken seriously, since the average age of suitable stars within the galactic habitable zone, in which the Earth also resides, is found to be about 10 billion years older than the Sun, suggesting the possibility of civilizations extremely advanced beyond your own.